And once again, grade 8, hi. So, aside from this one, aside from just multiplying your denominator to get your final denominator, you can have as well your LCD. Okay, so I got here 3 over b plus 5 over 2b minus 11 over 3b. So let's find the LCD for this rational expressions. Okay, so first, let's have the numerical coefficient. You got here 2 and 3. What is their least common multiple? Okay, so when you say least common multiple, when you get the multiples of 2 and 3, the lowest multiple or their common multiples, that's the least. Example, we got here 2. What are the multiples of 2? You have 2, 4, 6. For 3, you got 3, 6, 9. Okay. So among these multiples, you got 6 as their common multiple, and that's the least. Therefore, that is your LCM for the numerical coefficient 6. For the variable, no need to compute, just get the exponent or the highest exponent of your variable. Sample for this, you got b, and their highest, and the highest exponent for this is 1. And since pare-pareha sila, you got 6b, and that is already your LCD. Next, for this one, 2a plus 3b over 3 plus 3a minus 2b over 5. So for the LCD of this one, you're just gonna multiply. Okay, so once again, if you list down all the multiples of 3, you will have 3, 6, 9, 12, 15, 18. If you list down the multiples of 5, you will have 5, 10, 15. So among these multiples, their common and their least common multiple is 15. Therefore, 15 is your LCD for this rational expression. So you may simply just multiply this one. Next, we have this 5 over m squared minus n squared plus 2 over m plus n. So first, let's factor out m squared minus n squared. So this is an example of difference of two squares. Okay, so how to get the factor of this one? Yeah. So one binomial is positive, the other one is negative, plus minus. Okay, and then get the square root of m squared. You will have m. Put it here as the first term of your binomials. And then n squared, get the square root of n squared, that is n. Okay? So this is the factored form of m squared minus n squared. Okay. So what is the LCD for this rational expression? Since m plus n is already or a factor as well of m squared minus n squared, no need to multiply or no need to multiply m plus n with this one. So you can simply have m squared minus n squared, and that is already your least common denominator. Okay. Next, we got 5f over 6gh plus f over 6g squared h squared. So how do we get the least common denominator for these rational expressions? And since you have here, they're common with the numerical coefficients. So just type or write 6 here. Okay? Since once again, if you list down the multiples of 6 and 6, their least common multiple is 6. Next, for the variables, get the variable with the highest exponents. So we will have g squared, h squared as well. Okay? Ayan. G squared, since this is the highest exponent for g, and h squared, since 2 is the highest exponent for h. Okay, and we have completed this already, finding the LCD of the following rational expression. Now our next task is to perform the operations. Okay, let's just go back here. And instead of having just the LCD, we're gonna evaluate these rational expressions. So knowing the LCD, let's perform how to add fractions or rational expression with unlike denominators. So what they're gonna do, 6b Okay. Divided by b. How do I put it here so you could visualize? So let's make it like this. I guess you can visualize it like this one. They're common. Um, they're common or their denominators are same, 6b. So 6b divided by b, that's 6 times 3. 6 times 3 here. Next, 6b divided by 2b. By the way, this is minus. Okay, just gonna copy the sign. 6b divided by 2b, you got 3 times 5. 3 times 5 minus 6b divided by 3b, that's 2b. Or sorry, that's 2 times 11. Okay, now you are dealing with a rational expression with same denominator. So simply copy your denominator. You will have 6b and then proceed with adding this or evaluating your numerator. 6 times 3, that's 18. So you will have 18 plus 3 times 5, that's 15, minus 2 times 11, that's 22. So 18 plus 15 minus 22, that is 11. 11 over 6b. Is this the final answer? Yes, this is already your final answer since they do not have any common factor aside from 1. Okay, they are relatively prime to each other. Am I correct? Uh, 18 plus 15, 33 minus 22, 11. Yes. Okay. Next example, we got 2a plus 3b over 3 plus 3a minus 2b over 5. Knowing that their LCD is 15, let's write it like this one, just like in number 1. Okay, so 15 divided by 3, that's 5. 5 times your numerator, you got 2a plus 3b plus 15 divided by 5, that's 3 times your numerator, 3a minus 2b is equal to, and so we will distribute this one, uh, these factors to each term. You have 5 times 2a. Let me show you like this one. 5 times 2a, that's 10a. 5 times 3b, that's 15b. And then let's have over here, plus 3 times 3a, that's 9a. And then 3 times negative 2b, you have negative 6b. Still over 15. Since you have same denominator, just copy it. We're not yet done. We need to combine like terms. Okay, so let's combine 10a and 9a. So 10a plus 9a, that's 19a. And then for this one, 15b minus 6b, you have plus 9b over 15. Do they have common factors? None. Therefore, this is already your final answer. Okay? 19a plus 9b over 15. Since all the numerical coefficients are relatively prime to each other. Next, let's have this. Third example, we got 5 over m squared minus n squared plus 2 over m plus n. Okay, so just like the other two example, let's put it in this way. So m squared minus n squared divided by m squared minus n squared, that's 1. So 1 times 5, absolutely that's 5. Next, m squared minus n squared divided by m plus n. Well, when you divide this one by this factor, what will remain? M minus n. We got 2 times m minus n. Okay? And then we simplify. Okay? We're dealing with common denominator, same denominator, so just copy m squared minus n squared. And then evaluate your numerator. So 1 times 5, that's 5, plus distribute. 2m minus 2n. Okay? Is this the final answer? Yes, this is the final answer already. Okay, since they don't have any common factor, they are relatively prime to each other. Okay, and you can't simplify this or cancel out terms simply because this one is trinomial, this one is binomial. Okay, next let's have another example. We got 5f over 6gh plus f over 6g squared h squared. Okay, and we got here your least common denominator. So what to do? We got 6 g squared h squared divided by 6gh. Okay, let's put it this way again. Okay, so we're not going to be confused. 6g squared h squared divided by 6gh, we will have 1gh times 5f plus 6g squared h squared divided by 6g squared h squared, that's 1. So 1 times f is equal to, and so since you have same denominator, just copy your denominator. 6g squared h squared. It's your same denominator. Just copy it. And then evaluate your numerator. You got gh times 5f. You will have 5fgh. Okay, so even if it's rambled, your variable, that's okay. Plus, but I prepare it to be in order. Next, 1 times f, that's f. Is this the final answer? Yes, this is already your final answer. So this how we add and subtract rational expression with unlike denominators. And so thank you. Do you have any question? So lastly, it doesn't matter how slowly you go as long as you do not stop. So the process might be long, might be might really be long, but of course you'll come up with the correct answer if you proceed with the step-by-step process. Hello?